Hello everyone. In this session of CCNA series, I'll discuss about VLANs. Also, I'll discuss about broadcast domain, benefits of VLAN, and different types of VLAN. As you know, a local area network is a collection of different devices, and all those devices are in the same broadcast domain. The term broadcast domain is used to describe a group of devices on a specific network segment that can reach each other with Ethernet broadcast. By default, all the interfaces in the switch are in the same broadcast domain. Let's say to create two different LAN broadcast domains, you need to buy two different Ethernet LAN switches, which is very expensive. So this is where a VLAN is required. VLAN, also known as virtual LAN, is a logical grouping of network devices, where when we create a VLAN, we actually break large broadcast domain into smaller broadcast domains. VLANs are configured on switches by placing some interfaces into one broadcast domain and some interfaces into another. VLANs can be spread across multiple switches. Each VLAN is treated like its own subnet or broadcast domain, which means that frames broadcast onto the network are only switched between the ports within the same VLAN. For communication between VLANs, you need a device, a layer 3 device, or a router, or a switch SVI interface on a layer 3 switch. Let's discuss about benefits of VLANs. The primary benefit of using a VLAN are as follows. Improved security. Groups that have sensitive data are separated from the rest of the network, decreasing the chances of confidential information breaches. As shown in the figure, faculty computers are on VLAN 10 and completely separated from student and guest data traffic. Another benefit is cost reduction. Cost savings result from reduced need for expensive network upgrades and more efficient use of existing bandwidth and uplinks. Another benefit is better performance. Dividing flat layer 2 network into multiple logical work groups such as broadcast domains reduces unnecessary traffic on the network and boosts performance. Another benefit is smaller broadcast domain. Dividing a network into VLAN reduces the number of devices in the broadcast domain. As shown in the figure, there are 6 computers on this network, but there are 3 broadcast domains: faculty, student, and guest. Another benefit is IT efficiency. VLANs make it easier to manage the network because users with similar network requirements share the same VLAN. When a new switch is provisioned, all the policies and procedures already configured for the particular VLAN are implemented when the ports are assigned. It is also easy for the IT staff to identify the function of a VLAN by giving it an appropriate name. Another benefit we have is simpler project and application management. VLANs aggregate users and network devices to support business or geographic requirement. Having separate functions make managing a project or working with a specialized application easier. An example of such an application is an e-learning development platform for faculty. So before we discuss about different types of VLAN, we should understand the switch port types. A switch port can be in one of two modes: access port and trunk port. Access port is a port that can be assigned to a single VLAN. The frames that arrive on an access port are assumed to be part of the access VLAN. This port type is configured on a switch port that are connected to a host on a network. Trunk port is a port that is connected to another switch. This port type can carry traffic of multiple VLANs, thus allowing you to extend VLANs across your entire network. As you can see from the picture, the ports on the switches that connect the host are configured as access port. The ports between the switches are configured as trunk ports. Now we know about access and trunk port, let's discuss about different types of VLANs, starting with default VLAN. All switch ports become a part of the default VLAN after the initial boot up of a switch, loading the default configuration. Switch ports that participate in the default VLAN are part of the same broadcast domain. This allows any device connected to any switch port to communicate with other devices on other switch ports. The default VLAN for Cisco switches is VLAN 1. As shown in the figure, the show VLAN brief command was issued on a switch running the default configuration. Notice that all ports are assigned to VLAN 1 by default. Another VLAN we have is data VLAN. A data VLAN is a VLAN that is configured to carry user-generated traffic. A data VLAN is sometimes referred to as a user VLAN. Data VLANs are used to separate the network into groups of users or devices. Another type of VLAN we have is native VLAN. Native VLAN is assigned to 802.1q trunk port. A trunk port supports traffic coming from many VLANs, that is tagged traffic, as well as traffic that does not come from any VLAN, untagged traffic. The trunk port places untagged traffic into the native VLAN, which by default is VLAN 1. It is a best practice to configure the native VLAN as unused VLAN, distinct from VLAN 1 and other VLANs. Then we have management VLAN. A management VLAN is any VLAN configured to access the management capabilities of a switch. VLAN 1 is the management VLAN by default. Note, because of the out-of-box configuration of a Cisco switch has VLAN 1 as the default VLAN, VLAN 1 would be a bad choice for the management VLAN. To create the management VLAN, the switch virtual interface of that VLAN is assigned an IP address and subnet mask, allowing the switch to be managed via HTTP, Telnet, SSH, or SNMP. That's it for this session. I hope this